All right, so we're going to move on to example number 4 here, another example of using the inverse function. And so if you take a look, right, all the trig ratios or the trig functions are the same. So this looks suspiciously factorable. So why don't you factor it, because it is. Let's use 4 tan of x over here. And over here, this would be a single tangent of x, right? Because this times this will give you 4 tan squared x. And factors of 6 that give me 5, it's going to be minus 3 and plus 2. You can double check your work, right? Negative 3 tan x times 8 tan x. Does that give you positive 5 tan x? And it does. Okay, so you could use the zero product rule from here, right? 4 tan of x minus 3 is equal to 0. Tangent of x plus 2 is equal to 0. Isolate your tan function. Tan of x is equal to 3/4. And tan of x is equal to negative 2. All right, so again, before we use our arctan function, you have to kind of recall the restrictions, right? Recall that y is equal to arctan of x if and only if, right, tangent of y is equal to x. And the restriction was that this number inside my argument has to be between pi over 2 and negative pi over 2. And whatever's outside the argument, right, there is no restriction. X can be anything. And so this number on the outside, right, could be anything, right? X can be between negative infinity to infinity. Don't get that x confused with this x, okay? So just think of this number outside here. Okay, so there are no restrictions. That means if we use our arctan function, x is equal to arctan of 3/4. That will give me an exact solution. Or x is equal to arctan of negative 2. All right, now is where I'm going to use the calculator to see what the approximate answers are. These are exact. Now the approximate solution, so I know, if these answers or solutions fall in the interval from 0 to 2 pi. So when you enter it on your calculator, right, arctan of 3/4, again, make sure you're in the radian mode. You're going to get approximately 0.643. On this one, right, if you hit the arctan button, arctan of negative 2, I believe you're going to get negative 1.107. Okay, so at this point, you think you're done. Okay, remember, from the intervals from 0 to 2 pi, right? This is from 0 to about, 2 times 3.14. That's about 6.28. So both of these numbers, right? Actually, this number right here does not fall in this range from 0 to 6.28. Okay, so I'm just going to keep it here for a second because you will see that we're going to find another solution. Okay, this number clearly does fall in that range. All right, now, before we move on, this is where your calculator doesn't give you all the answers, right? You know by your knowledge of the unit circle that tangent is positive in quadrant 1 and quadrant number 3, right? So let's draw this out here. Over here, this is about 0.643 radians, right? This is what I got for my theta. Well, where else is tangent positive? In quadrant 3. So if it's in quadrant 3, right, it's a full pi radians to get from here to here. And so if I take 0.643 and I add another pi, this value right here, right, 0.643 plus pi is 3.78. Right? And your calculator is not going to give you that 3.78 radian value. You have to figure that out using your knowledge of the unit circle. So x is approximately 3.78. And you can even check your work, right? What do I mean by checking your work? Enter tan of 3.78 here. Tangent of 3.78, right? It should give you around 3/4, and it does, okay? So make sure you know how to get this other answer by sketching this out, knowing that tangent is positive in quadrant 1 and quadrant 3. And 3.78 clearly falls within this range, right? Now, obviously, this is not going to be in this range, right? But tangent is also negative, both in quadrant number 4, right? So maybe this is negative 1.107 radians, and quadrant number 2. So again, to get from here to here, I add a full pi. Okay, so take your, negative 1.107, and you add a full pi. This is going to be 2.03 radians, right? Again, your calculator is not going to give you this answer. You have to figure it out by sketching it. Okay, 2.034. And again, that is going to fall in this range from 0 to 6.28. Okay, so just like the last example, right? Your calculator will give you this answer and this answer, right? Of course, this doesn't fall in the range from 0 to 2 pi, but you have to figure out this and this using your knowledge of quadrants in the unit circle. Okay, so that's really the trick to it. Okay, so the answer to part 1, right? 0.643, 3.78, 2.034. For part 2, you could just write the exact solution. You could say x is equal to arctan of 3 over 4, right, which will give me this answer. But to get me this answer, any answer after that, right, I have to add pi n, right, because they are separated by a full pi. For this one right here, you could write x is equal to arctan of negative 2. And arctan of negative 2, right, is negative 1.107. But to get infinite number of solutions, to get this answer, and then to keep going back and rotating to get a multiple of this answer, I add a full pi n. And that will give you the general solution to this problem. Okay, so again, whenever you're solving using inverses, oftentimes what trips up students is they have to know their unit circle. They have to know, how do I get my non-calculator answer? How do I get my non-calculator answer? Okay, so my suggestion for you guys is just to draw it out and to see where the other answer lies. Okay, so the very last problem right here is a calculator problem. It says approximate the solutions of 4 cosine x is equal to x in negative pi to pi using a graphing utility. All right, so if you remember, right, when you're solving the solutions in any function, you're really just finding the x-intercepts. And so this will be useful in your homework on page 373, 49 to 54, where it says, collect all the terms, use the graphing utility. I would just recommend going to desmos.com again. And so I just move all the terms over, right? And basically enter this, right? This is basically your function. And when you're setting it equal to 0, right, you're and solving for x, you're basically finding where the x-intercepts are. Okay, so I already gone to desmos.com, so if you kind of take a look at my computer over here, I entered 4 cosine x minus x, right? And I just want to see, I believe the solutions were from negative 3.14 to 3.14, right? Negative pi to positive pi. You just kind of scroll over here, right, and just read whatever that value is. Negative 2.133. And looks like this number right here also is under pi, so 1.252. And those are your only solutions in the interval from negative pi to pi. Okay, so that will conclude this lesson on solving trig equations.